Hey guys, Mr. Jenkins here, and as I said yesterday when I was on the video for 4.1, that we would be skipping ahead in the chapter to 4.4. So no, you have not fast forwarded the time. This really is the video for 4.4 because that's the next one that we are covering, because that is all material from 4.2 and 4.3 won't be directly tested. So your learning target for 4.4 is we want to be able to graph equations that represent functions. All right, so we'll be looking at a lot of linear functions, which leads into next chapter, and even some nonlinear functions. Our vocab words are continuous graph and discrete graph. All right, so we'll talk about that. That might be a new idea for you. And then a key idea here, the equation of a line in slope-intercept form is y, I know that's hard to see, y equals mx plus b. Let me write that out. I don't know if you can see that on your screen or not. Y equals mx plus b, where m is the slope of the line and b is the y-intercept. All right, so on that note, we will start with example 1 on identifying slopes and y-intercepts. So we're just going to refer to slope as m and y-intercept as b. All right, so looking at A, it says y equals. That means that it is in slope-intercept form. In other words, I do not have to solve for y, which you've done in the past. Okay, I can just pick out m and b. So m is the coefficient of x. That means that the slope of my line, also known as m, is 2/3. The y-intercept is the constant, okay? So -4, that is the same thing as -4. So we would say b equals, and you could just say -4. I'm going to list that as an ordered pair because a lot of times people graph the wrong point on the graph. So m is 2/3, b is the point 0, -4. Looking at the next one, it is not in slope-intercept form, right? So if we want to identify the slope and the y-intercept, we need to get it there. In other words, we need to solve for the y. So to have y by itself, all we need to do is move plus x over to the other side. So the question is, how do I do that? And the answer is, if it's plus x, we want to do minus x to both sides. Or the way I think of it is, if it's positive x over here, it's negative x over there. So this equation is equivalent to y equals negative x or negative 1x plus 6. All right, now we're able to find m and b pretty easily. So m is negative what? So that's a -1. That's an understood -1. I think most of you guys seem to get that. And then b is 6. So we're going to say b is the point on the graph 0, 6. I will leave the next 3 for you to do and then check. Make sure that you guys kind of do that for extra practice. All right, getting to example 2 here. So it's graphing linear function rules, discrete and continuous. So now we're going to get into what a discrete graph looks like. All right. So kind of coming up with your points, and this means the domain is -4, -2, 0, 2, and 4. So the domain is the x values they want us to use, or input values. All right, so they only want us to basically plot the points for this table right here. So they've given us that they want us to find the output that goes with -4, -2, 0, 2, and 4. So I'm going to use my calculator in order to do that. There's another way you could approach this problem, but I'm going to use the calculator. So if you look over here, I'm kind of ahead. I went ahead and typed it in. -3/2 times -4 minus 1. And that is equal to 5. So -4 goes to 5. All right, I'm going to go ahead and put that on the graph. -4 goes to 5 would go right there on the graph. Now we want to do the same thing for -2. I was hoping I could just repeat that. Not gonna let me do it. All right, so I might start to go a little bit quicker here. So -1.5, that's -3/2 times -2, and then -1. I think in your calculators, you'll be able to just go back and replace this number each time. Anyways, that goes to 2. -2 goes to 2. And then from there, I'm just going to go ahead and tell you the answers. All right, just so I don't take too much time on the video. 0 goes to -1, and really, if you just follow the pattern, we can see it's linear. We could kind of come up with these just using that kind of logic. So the next point would be, if you look at our slope, down 3/2. If we follow that pattern, go down 3/2 more, we can see that 2 goes to whatever that is. It'd be -4. Repeat that one more time. Down 1, 2, 3, right 2. And that would be that 4 goes to -7, I think. 1, 2, 3, 4, 5, 6, 7. So we used our calculator to get these first two, and then we kind of followed the pattern. Now, what you're going to want to do there is you're going to want to kind of draw your line, because that's what you've always done. But if they give you a domain, all they want is those points, okay? In other words, you don't really connect the dots or draw your line for a discrete function, okay? So I'm going to write that down. Don't draw line for discrete. And again, how did I know it was discrete? Because of this right here. They gave me a domain, right? So I want you guys to kind of look at the notes for example B. The math is a little bit easier. So again, maybe try that one on your own or think ahead and then check your math there. All right, don't need to go to the next page. I just need to scroll down. All right, so next example is going to be very similar, right? But notice they don't give me a domain. So if they don't give you a domain, you need to assume that it is continuous. All right, so if it's continuous, you could do the same thing we just did. You could use a t-chart to come up with a couple X's and Y's. You can sub in whatever you want. Like maybe you could sub in 0. What's 2 times 0 minus 1? Looks like it's -1. So 0 goes to -1. Right? Notice that is the y-intercept, right? So really we could have kind of, if we understand slope-intercept form, we could have kind of just looked and known that point. Then if we just sub in any other number, we'll kind of have a good picture of what our line looks like. So if I sub in 1, for instance, 2 times 1 minus 1 would be 1. So 1 goes to 1. And this is a linear equation. So at that point, I can tell that really I can just follow my slope. Up to right 1. Or I could also go down to left 1 to stay on that same line. All right, at that point for a continuous graph, and I know it's continuous because they didn't give me a domain, I am going to go ahead and draw my line extended through the points. Kind of with an arrowhead showing that it does go on forever. Trying to get it to look good for the notes. There we go. And again, I like to just draw that arrowhead. That shows that it goes forever on that line. Okay, so any point on that line is a solution or is part of that linear equation. Now, if you don't need to do all this work, that's fine. Okay, you've done this in pre-algebra a bunch. If you can do like D and just say, okay, I can just look at that and tell it's in slope-intercept form. So I'm going to start at 0, 2. Put your first point there, and I know that m equals -4/3. So that could mean that I go down 4 and right 1, 2, 3. Or it could mean that I go up 1, 2, 3, 4, and left 1, 2, 3. Okay, if you want to just graph it that way, that'd be just fine. Okay, just make sure for those discrete graphs, like the first couple examples there, that you get the points that they are looking for and that you don't connect the dots. All right, so that's that. And then moving ahead to a word problem here. It says a local cheesemaker is making cheese wheels to sell at a local farmer's market. Each wheel of cheese costs $9, so the function 9n plus 5 models the amount of money earned, A, given the number of cheese wheels sold, N, right? It wants us to basically just graph this, and they give us the model, right? So N is normally where X is, right? So if we have N wheels of cheese, what does that make A? Right, A depends on N. Let me put that N in the right spot. Okay, so let's see. All they want us to do is model the situation. So what we're going to do is just come up with a few points, right? So what if I sub in 0? 9 times 0 plus 5 would be 5. So 0 goes to 5. Also, if this is a real world problem, which it is, we would want to kind of label each axis. So A is the amount of money earned. So I'm going to call that profit. And then N is the number of cheese wheels. All right, so 0 goes to 5. Let's see, 1 goes to 9 plus 5 would be 14. Actually, so since we're going to have bigger numbers, I should have thought of this at the beginning. I'm sorry. I'm going to scale this down a little bit. So let's say let's count by maybe 5s here, so we can fit a few points on the graph. So the 0, 5, that'd be 10, 15. The next one would be 20. I'm going to just scale it up a little bit. Give it a second to catch up. And I won't do too big of numbers. So I'll kind of just stop there, and then we're counting by 1s here. No need to scale up our x-axis. All right, so if you can't see that, that just says the next one's 2, the 2 over is 4, and then 6, 8, 10. Okay, so 0, 5 would be like right here instead. It would look like 0, 1 if I'm counting by 5s. 114 would be, okay, that's 15, so just underneath that line. Then let's skip ahead a little bit. Let's see, what if we sell 5 cheese wheels? So that would be 9 times 5 plus 5. That'd be 50. So 5 goes to 50. There's 5. Y equals 50 is we're going to be right. Let's see. I guess I put 30 instead of 50. That should be 50 right there. And then when that point pops up, you'll see that it's kind of on the same line as these two. I'm just waiting on it to pop up. My computer's a little bit behind. Maybe it'll pop up. We'll see. There it is. All right, so, you could do another one if you wanted, but we can see the picture. Now, the next question would be, is this discrete or continuous? All right, so, could you sell any cheese wheels between these 2 points? And I would say in this scenario, the answer would be no, right? You probably wouldn't sell half a cheese wheel, so we would keep this one as a discrete graph. Okay, in other words, we wouldn't connect the dots. All right, if we wanted to put a few more points, it might look a little better, but I think you get the gist of it there. Okay, so what I'll do is I'll go ahead and make that the day 1 video, and I'll post the whole assignment for you if you watch ahead, but then I'll do example 4 on day 2, and we'll kind of spend 2 days on this in class since it's got lots of different types of questions. That's probably enough for 1 day there. So I'll go ahead and cut it off and pick up with example 4. That'll be your next video. Thanks for your time. As always, hopefully these help, and y'all have a good one. Bye.